All right, so I'm just going over the predicting products review homework here on Monday. So this is in the key. I've done a couple things already just to save a little time, but I'll talk through each of them. So remember, the key for predicting products is first identifying the reaction based off of the reactants. Okay, so on the left side of my arrow, I have my reactants, and when I have a carbon compound, something that starts with carbon and O2, that tells me it's combustion. Single replacement is an element, usually a metal for us, and an ionic compound, which is a metal in this case with a polyatomic ion. I got double replacement, two ionic compounds, Na and Fe are going to switch spots. Synthesis, two elements, a metal and a nonmetal. And then this one says decomposes, so that's telling me I get decomposition. Also, chromium 4 nitrate is a reactant. And just a review of crisscrossing. Remember, this charge here from nitrate is going to come down to the Cr. I don't write ones, right? So I would normally think 1 here. Wouldn't put that in though, don't need it. And then I need 4 NO3s. So the big key here is that the 4 needs to go outside of the parentheses. Okay, so it needs to be there and then a 4 there. I need 4 NO3s. If I wrote a 4 right here, it would just be 34 oxygens, but I need 4 NO3s. Okay, so that's the actual compound that I'm writing with here. Okay, so I'm just going to copy and paste this. So now, writing products. Yeah, I'm just going to write them here. So, combustion reaction, carbon compound and oxygen. The nice part is it always makes, oops, oh, wrong button. That's why CO2 and H2O. Okay, so that means those two products are always going to be the same for my ionic compounds, or sorry, for a combustion reaction. Come back and balance later if I got time. So here, Na and B are switching spots, so that means Ba has to go here, and Na has to go here. Oh, that 4 needed to come along. But in order to do this problem effectively, I have to crisscross these charges. So my polyatomic ions list right here, I see that SO4 is a 2. That's the charge there. Na is a 1. Okay, so when I'm coming back here, that means I'm starting with -2 up here and a +1 up there for my charges. Notice the positive charge is always written first. So the 2 is going to come down to the Na. So the 2 is going to come down here. Na2, and then that 1 is going to go to SO4, but as it's written is correct. Okay. Similarly, as I switch Na and Fe here, I could write it either way I wanted to. I'm just going to put Fe in right there, and I'm going to put Na over here. Okay. So now I have to figure out charges of these things. I'm going to start with NaCl, so that one's a little bit easier. Na is a 1, Cl is a 1. So actually, it's just NaCl. That one's done. The ones cancel out. Now, as I saw right here, SO4 is a -2. Okay. Now, the tricky one here is iron, which can be a +2 or a +3 based on our periodic table. So what I have to figure out is based off of this compound, which charge of iron did I use? Well, Cl is a 1, so the 1 will go down there, and then the 3 will go to the Cl. So that means iron was a 3. So now I'm going to crisscross these. I get Fe2 and then SO4, 3. Okay. For synthesis, I put Al and F together. Now aluminum's charge for my periodic table is +3. F is -1. So when I crisscross, I get 1 Al and I get 3 Fs. Oops, and 3 Fs. So that's how I effectively balance that one. In a decomposition reaction, Cr, N, and O all split up. Okay. So I'm going to split them up here. And then I have to decide, are any of these sneaky 7s, meaning do they get 2s on them? Chromium is not a sneaky 7, so it doesn't get a 2. N is a sneaky 7, so it gets a 2. And O is a sneaky 7, so it also gets a 2. Okay, so that's the final one for my answer here. That's my final answer. Okay. Now, moving on to the second set of problems here. I'll come back and balance at the end if I got time. So, first one, copper reacts with nickel 2 phosphide. That's single replacement because as I write it out, copper is Cu, nickel 2 phosphide is a crisscross of nickel plus 2 and phosphorus minus 3. That's the compound down here. So when I'm going to switch these, copper, which is a metal, will switch spots with nickel. Okay. And then copper is going to go over here. Now, the 3 from the P, if I were to crisscross this one on this side, so I'll just tab it over. So here, Cu is forming a +1 charge. Assume copper forms a +1. So when I crisscross them, the 3 goes to Cu, the 1 goes to P. So I just get Cu3P. Okay. Next one is a combustion reaction, which the products for combustion are always CO2 and H2O. So that one's pretty straightforward. Here, I get nickel, nitrogen, and oxygen all splitting up. Oxygen and nitrogen are sneaky 7s. Nickel is not, so that one is balanced as it is. Okay. Here, synthesis reaction, decomp, you just split it into the elements, which I did there. Here, synthesis, I got a crisscross. So I'm going to need to look, what is my charge of W or tungsten? It's a +6. Phosphorus is a -3. Okay, so I'm coming back. Tungsten is a +6, so I'm going to put that in. And -3 is P. Now the question, when I crisscross, really what you're doing is you're balancing charges. So based off of this information, how many -3s does it take to balance a +6? Well, as we'll see in a minute, it's going to be WP2 is my final answer, but let's figure out how we get there first. Oh, I'm going to do it this way. So when I crisscross, the 3 comes down here, right? So I'm going to get 3W3 P6. But in ionic compounds, I reduce. So I can reduce 3 and 6 both by 3. So I get W1 P2 to give me WP2. Okay. Last one, I got COIO4. Cobalt here is a +3, and potassium crisscrossing with S, which is a -2. So K is coming over here. And then say I don't know what IO4 is, I can look on my periodic table, polyatomic ions list to find it. It's right here. It's periodate. It's a -1 charge. Now it's going with potassium, which is a +1. So those charges actually cancel out, and I just get KIO4. You could write it with parentheses or without. I'm just going to leave the parentheses because I think it's helpful for a lot of you to visualize it. And now CO, which is a, as we just saw, +4 is going with S, which is a, -2. Not sure what I just did there. So again, similar situation to the WP2. How many -2s does it take to balance here? Well, if I crisscross, I'd initially get a 2 there. And a 4 here. What can I reduce 2 and 4 by? 2. I get COS2. Okay, so that's how we predict products. I'll get as far as I can balancing equations here. And then if the video time runs out, the video time runs out. Combustion problems, you're starting by balancing your carbons. So I need a 6 there to balance my carbons. And then to get 14 H's, I need to put a 7 here. The reason I do oxygen last is because I have it in 2 spots here. So 6 times 2 is 12. 7 times 1 is 7. That gives me 19. So 2 times what gets me 19? Ooh, actually nothing. So I need to go double here, and double here. And now I'm going to have 38 on this side instead of 19, which gives me a 19 there. 19 times 2 is 38. Okay, so that's a tricky one. If you get an odd number of oxygens on this side, a lot of times you got to come back and double your first compound here. To balance this one, all you need is a 2 there. Remember, blanks are 1s. So I can just delete the blanks. I'm going to start by balancing whichever one I want to start with. If you start with NA, you're going to have to come back to it, but I'll just do it to be consistent here. So I get 2 NAs, that gives me 2 CLs. Oh, but over here I have 3 CLs. So to make those balanced, I actually need to find the first number they both go into, which is 6. So I got to change that to 6 and put a 2 here. But that also means that I'm going to have to change my NAs. I need 3 of them now. So 3 times 2 is 6. Over here I have 6. And then this is a 1. So we're all balanced there. Okay, this one balancing. I got 4 Fs and 3 Fs, so I got to make it 6 just like I did above. It gives me 2 there, and then I got to put a 2 in front of my AL. Here I got 12 O's, 4 N's, and 1 CR. So to get 4 N's, I need a 2 here. In order to get 12 O's, I need a 6 here. And then I got 1 CR and 1 CR, so I'm actually all good there. Now this one, this single replacement down here, I got 1 CU, 3 CUs. Okay, so I'm going to have to put a 3 here. 3 N's, 2 P's. 3 N's, 2 P's. Okay, so I'm going to have to make some adjustments here because now I got 2 P's. That gives me 6 COs. So this has to be a 6. I got 3 N's, 2 P's, 2 P's. Okay, so now I'm all balanced. That's just a 1. Okay, perfect. Here for CO2, I'm going to need an 8 C's. 9 times 2 gives me 18 H's. That's 16 plus 9 is 25 O's. So notice I can't get to 25 here, so just like the one above it, I have to double. If you get an odd number of oxygens, you're going to have to double. 16, 18, and that'll give me 50 over here actually, so that's 25 O2. Okay. Similar case where I have an odd number of oxygens here, and here I have an even. I'm going to have to double this in order to get an equal number. That's going to give me 2 N's. It's going to give me 2 Ni's. 3 N's times 2 is 6. So I need 6 over here, which is 3. That's a 2. And then 3 times 3 is 9 O's. Times 2 is 18. So to get 18, I need a 9 here. 2, 2, 3, and 9. I can't reduce those by any whole number, so that tells me that I'm all good there. To balance here, all I need is a 2 for my P's. That's a 1, and that's a 1. And this one's a little bit tough. Start wherever. I'm going to start with S's because that's going to be the easiest. I'll start somewhere where maybe you did. So I'm going to start with COs. I got 1 and 1. Good. IO4, I need a 3. So over here, I need a 3. That gives me 3 Ks and 2 Ks. Oh. So before, when I got 3 and 2, I got to make them into 6. So that gives me a 3 here. It gives me 6 Ks, 3 S's, and 2 S's. Oh, so I'm going to have to make those into 6 as well. And maybe you get stuck here. I'm actually just going to start from a different place then. Okay. You're like, oh man, this is really complicated. I'm going to start by doubling my S's to 2. 2. Okay, I got 4 Ks. Oh, this is why. There's a mistake right here. Cobalt was a 3. So this should be a 3, and this should be a 2. That's going to make a lot more sense now. I was trying to figure out why it wouldn't work. Yeah, I need 2 cobalts, so this should be a 2 right here. Now I got 3 S's, so I got to put 3 here. That gives me 6 Ks. 6 IO4s, 2 times 3 gives me 6 IO4s, and 1, I'm actually all balanced now. So sorry, that was an incorrect crisscross. Confused myself there for a second. So there we have it. That's our homework 2 key. Hopefully you're getting predicting products pretty good. Good luck, and I'll talk to you guys soon.